My name is Alice Shannon and I'm doing a material science PhD in relation to 3D printing, and my background is physics and material science.
And my name is Emma Jude Lyons and I'm doing a PhD with the Rapid Innovation Unit on 3D printing at the point of care for breast cancer patients, and my undergraduate is in product design from UL.
Our project is called re-PET3D.
So the aim of our project is to recycle waste plastic water bottles from the UL campus and process them and turn them into 3D printing filament that can be used then for a variety of different reasons.
So we're looking at local waste to shorten the supply chains, and then we'll also be using the 3D printed filament locally, again shortening the supply chain. So we had a look at the UN sustainability goals, and then we had a look at our own skill sets to see how we could apply those to the sustainability goals specifically.
As my background is in product design and Alice's background is in physics and material science, and our common background is in 3D printing, we use both sets of skills combined together with our 3D printing in order to address some of the sustainability goals, and that's where our project leaded into 3D printing filament from recycled plastic bottles.
We were delighted obviously to be selected as finalists for the UL sustainability project. Once we found out, then we immediately started looking at what items to order, what was within budget. We kind of made a decision early on that we wanted to scale up the project after, that we wouldn't be focusing on just the deadline between November and April. So we were able to invest really well in the shredder, the dryer and the filament extruder. Once you get the plastic bottle, you need to cut the label, remove it, remove the glue, remove the cap and then the seal that holds the cap on. And then, because we're collecting the bottles from the UL community, they need to be washed and then dried, and then they move on to the next stage of the process.
So we then put the plastic bottle into a shredder. So this grinds up the material and also granulates it. So then it comes out the bottom. We have to re-dry it again in case any moisture has been collected in that process. And then we put it into an extruder. So you're putting the granulation and the flakes into the extruder and you're coming out with this at the end. So this is the plastic water bottles that we collected from the UL campus, and it has been turned into this filament.
We have a few ideas for scaling up.
We want to collaborate with the UL Makerspace in the library, product design technology and other engineering groups around the campus in order to collect their support material that they would have used in printing, and also their failed prints, so that we can actually take that waste, recycle it and turn it into proper 3D printing filament that we can then use and give back to those said groups as well.
Yeah, we're delighted to be a finalist in the UL Sustainability Challenge. We focused initially on just getting past the pitch stage, and we didn't really expect much, but now that we're here, we're delighted that we've been given this opportunity to do this at this stage of our careers.
And with having such a high calibre of students and intellect on the campus, it's really uplifting and positive that we've actually been a part of the finalists and that we're here, and that our project that we've been working hard on has been so impactful. No, it's a real privilege.
If we were to win, it would be fantastic.
But I guess even if we weren't to win, we still have such an impactful solution that we have such big plans for, that we're going to be able to continue the work nonetheless. But of course, it would be fantastic to win.